EnergyWorks Insights is a toolkit focused on analytics across the trade lifecycle. From trade concept to cash in or out the door, Insights provides rapid analytics and application development tools for agile and rapid development of small projects in response to changing market requirements. This presentation is a deeper dive into components of the energy trade data management tools that the analyst, trader, risk manager, mid-office, or back-office analyst might need to fulfill their enterprise data needs. The Insights analytics process consists of specialized tasks orchestrated using a workflow. Each of these tasks can be categorized into data acquisition tasks, data preparation tasks, data storage tasks, data analysis tasks, data visualization tasks, data dissemination tasks, task orchestration, and operationalizing tasks. The first three tasks of data acquisition, preparation, and storage use tools from Insights Energy Trading Data Management Toolkit. In this slide, I'm going to provide a high-level view of the Energy Trading Data Management, or ETDM, tools. First, the data has to be acquired from a source. This source could be public, proprietary to a data vendor, or an internal system of record. Atomic and reusable data acquisition tools have been developed for commonly required datasets. These tools are available out of the box. An example of this is NYMEX natural gas futures settlements retrieved daily from the NYMEX FTP site. Once the raw data has been acquired, the data needs to be prepared for analytics. In the case of NYMEX natural gas futures, the source data is downloaded in the form of a CSV file. As part of the preparation stage, derived data is added to the dataset. Examples include converting the date fields into a form that takes up minimal storage space and adding relative month fields to each futures contract in addition to the contract month dates. Addition of expiry dates is another activity that uses reference data. Categorization of the contracts into summer, winter, and shorter months is also added. Data storage involves the storage of this data to one or more data stores as required by the analytical applications. This could involve writing the dataset to a relational and a columnar database. The data repository in ETDM is a polyglot made up of multiple storage engine types. Storage engine types include relational, columnar, graph, in-memory, document, and time series databases. The NYMEX futures data is stored to both relational and columnar databases. Data services is a broad swath of technologies that various stakeholders and enterprise systems use to access the data in the various repositories. Microapps are self-service web-based applications that allow the user to query individual datasets and retrieve windows of data as per their individual needs. Ad hoc OLAP queries are front-end user-facing applications where users can slice and dice the data using a drag-drop interface tied to each dataset. Enterprise integration is a category of tools developed to integrate the data repository with enterprise applications like ETRM, ERP, and CRM solutions, which are typically Tier 1 solutions and systems of record. Data APIs facilitate access of data to analysts and programmers alike who access data using their programming language of choice. Push services are a set of services that push data in real time to receiving systems using a push paradigm. Each dataset has an associated REST service that implements the various HTTP verbs, which makes accessing the data as simple as writing an appropriate URL in a browser. Data marts are specialized analytical application-focused blends of one or more datasets focused on exclusive needs of a particular application or function within the organization. Tools to serve up data in CSV and XLS file formats are meant for ad hoc applications built in Excel or for recurring export of datasets to be consumed by desktop applications or a means of integration with the lowest level of complexity and coupling. The microapps and self-serve tools allow the end user to define their criterion and extract data from the dataset. Additionally, small, lightweight, web-based or desktop applications can be built rapidly to provide specific analytical answers to various stakeholders based on the data in the datasets. Dashboards or custom interactive visualizations use these components. Insights provides an OLAP query tool. Each dataset is configured within the OLAP query tool. The tool exposes the dimension and facts that the user is allowed to query on. The user can filter the dataset contents using a drag and drop interface. The tool translates the criterion to a MDX query and runs that query against the relational data repository. The data obtained can be charted or exported to a CSV for use by the user. The enterprise integration components are tools written to export data to ETRM, ERP, and CRM systems. These tools provide interfaces from the data repository to enterprise systems using exposed APIs. This provides straight-through processing between ETDM and the Tier 1 enterprise systems. Data APIs are programming language-specific tools that are developed for use within specific languages. These tools are used by application programmers, quantitative developers, and end users alike for programmatic access to data in the repository. Support for numerical programming tools, generic programming languages, and data access technologies is available per dataset out of the box. Push services include WebSockets and Kafka-based messaging transports of data to consumers of the dataset. These services are used to send data to downstream user-facing or enterprise systems in real time as data becomes available. In most cases, these WebSockets and messaging-based transports are tied into back-end messaging infrastructure. REST services provide an implementation of data access components that allow individual datasets to be accessed using simple URL-based queries. The user can input a query into REST client tools such as Postman. In Postman, the endpoint can be accessed via HTTP verbs such as get, post, delete, patch, and put. Associated parameters can be added to the URL that can be used to extract data from the repositories in CSV, JSON, XML, or XLS formats. Data marts are driven by individual analytical applications. Users identify specific analytical applications and identify data needs for these applications. Data marts are then developed to blend various underlying datasets to meet the needs of specific applications. The structure of these data marts are tied to the use cases of the associated analytical applications. Running on a scheduler, program scripts can generate various files that users could expect to be available on a schedule and on a file share. These scripts, coupled with a scheduler or run on an event, can generate associated datasets and make those available in a comma-separated value, tab-separated value, Excel spreadsheet, JSON, and/or XML file. These files can then be consumed by various stakeholders or systems as required. This provides the most basic and loosely coupled integration point for ETDM repository data. The objective of autonomic data management using Insights Energy Trade Data Management is to reduce the data preparation time to 35% from 65%, so as to allow the analyst more time to analyze data and develop actionable value-adding insights. More information can be found at https://www.energyworks.com.